Hello everyone. In this video, we are going to discuss about genesis of periodic classification from the chapter 3 classification of elements and periodicity in properties of class 11 chemistry. You see, we know that the elements are the basic units of all types of matter. In 1800, only 31 elements were known. By 1865, the number of identified elements had more than doubled to 63. At present, we have 114 elements known. See, in this, the recently discovered elements are man-made elements. See, many scientists try to classify the elements in different ways. The attempt to classify the elements led to the development of the periodic table of elements. See, a German chemist, Johann Dobereiner, you see the pronunciation of the names of these persons or scientists would be different. Please excuse me for that. Anyway, a German chemist, Johann Dobereiner, he noted the similarity among the physical and chemical properties of several groups of three elements called triads. The group of three elements that was actually called as triads. You see, this table actually represents the Dobereiner's triads. Here you see, he actually noticed that the middle element of each triad had an atomic weight which is about halfway between the atomic weights of the other two. Also, the properties of the middle element were in between those of the other two elements. That is, for example, if you consider this triad, that is the group of these three elements, lithium, sodium and potassium. See, the atomic weight of lithium is 7 units, atomic weight of sodium is 23 units and atomic weight of potassium is 39 units. So, the middle element is sodium. Okay, the group of these three elements that is actually called as triads, in which the middle element is sodium. Its atomic weight is 23 units. So, Dobereiner noticed that the middle element of each triad had an atomic weight about halfway between the atomic weights of the other two. That means, atomic weight of the other two elements, 7 and 39. When you add 7 and 39, you will get 46. That divided by 2, half of that is actually equal to 23. Similarly, when you consider this triad, that is group of these three elements, calcium, strontium and barium, you see the atomic weight of strontium is about 88 units. So, when you add the atomic weight of calcium and barium divided by 2, you will get almost 88.5, which is approximately 88. Okay, similarly, when you consider the triads of the group of these three elements, chlorine, bromine and iodine, the middle element is bromine. So, when you add the atomic weight of chlorine and iodine divided by 2 will give you 81.25 actually, which is approximately equal to 80, which is the atomic weight of bromine. That is, according to the law of triads, when elements are arranged in the order of increasing atomic mass, the groups of three elements with similar chemical properties called triads are formed. In a triad, the atomic mass of the middle element is roughly equal to the average of the atomic masses of the other two elements. But this law of triads seemed to work only for a few elements. The next attempt to classify elements was made by a French geologist, A.E.B.D. Chancoteur. I think that is the pronunciation. It is written like this. Please excuse me for the pronunciation of the name of this geologist. Okay. See, he actually attempted to classify the elements in 1862. This geologist, he arranged the then known elements in the order of atomic weights, increasing order of atomic weights, or in the order of increasing atomic weights, and made a cylindrical table of elements. He used a cylindrical representation with elements arranged in spiral pattern. But this attempt did not attract much attention and was not widely accepted. Next attempt to classify the elements was of an English chemist, John Alexander Newlands. See, the law of octaves was a concept developed by Newlands. See, Newlands, he arranged the elements in the increasing order of their atomic weights, and he noted that every eighth element had properties similar to the first element. He noted that every eighth element had properties similar to the first element when he arranged the elements in the increasing order of their atomic weights. So he compared this phenomenon to the octaves in music where the notes repeat at intervals of 8. For example, when we consider the notes in music like sa, re, ga, ma, pa, da, ni, sa, the first one is sa and the eighth one is also sa. Okay, so for example, let us consider a row from Newland's classification of elements. We are considering this row of elements from Newland's classification. So if you take these elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and sodium, you see the lithium is the first one, second, third, fourth, fifth, sixth, seventh and sodium is the eighth one. It has been found that the properties of lithium and properties of sodium are similar. But Newland's law of octaves seemed to be true only for elements up to calcium. That is, not all elements fit in the octave pattern. See, Dmitry Mendeleev, a Russian chemist, and Lothar Meyer, a German chemist, are credited with developing the modern periodic law and periodic table, working independently of each other. See, Lothar Meyer, he plotted the physical properties of elements like atomic volume, melting point and boiling point against the atomic weight. He obtained a periodically repeated pattern. Based on this, he developed a periodic table similar to that of Mendeleev's. But Lothar Meyer's periodic table was not widely recognized. So when we come to the Mendeleev's classification, Mendeleev, he classified the elements in the increasing order of their atomic weights. He found that the properties of elements repeat after a regular interval. Based on this observation, he proposed a periodic law which states that the properties of elements are the periodic functions of their atomic weights. That is, when the elements are arranged in the increasing order of their atomic weights, their properties repeat after a regular interval. See, Mendeleev's periodic table contains horizontal rows called series and vertical columns called groups. That is, the rows of Mendeleev's periodic table was called as series and the columns of Mendeleev's periodic table was called as groups. See, the elements with similar properties were placed in the same group. While classifying the elements, he mainly depended on the similarities in the empirical formulae and the properties of the compounds formed by the elements. So, he did not strictly obey the increasing order of atomic weights. He also noticed that the wrong atomic masses of, he also actually corrected the wrong atomic masses of some elements. And you see, when Mendeleev proposed his periodic table, he proposed that some of the elements were still undiscovered and he left several gaps in the table. That is, this is actually the Mendeleev's periodic table which was published earlier. When Mendeleev proposed his periodic table, he proposed that some of the elements were still undiscovered and he left several gaps in the table. He actually left the gap under aluminium. And he left a gap under silicon. And he actually predicted the presence of two undiscovered elements and he left space for them in the periodic table and he called these elements as Eka Aluminium and Eka Silicon. See, Eka Aluminium, that is actually gallium, Eka Silicon, that is actually germanium. So, he actually predicted the presence of gallium and germanium, and he left some space for these two elements under aluminium and silicon. That is, he predicted the presence of two elements, undiscovered elements. He named these elements as Eka Aluminium and Eka Silicon. Eka Aluminium means gallium and Eka Silicon, that is germanium. He predicted not only the existence of gallium and germanium, but also described some of their general physical properties. These elements were discovered later and found that Mendeley's predictions were correct. But actually, there were so many demerits of Mendeleev's periodic table. That is, when we come to the Mendeleev's periodic table, the elements with dissimilar properties were found in the same group. And he could not give an exact position of, hydrogen atom. And you see, Mendeleev's periodic table did not strictly obey the increasing order of atomic weights. He couldn't give the exact position of lanthanoids and actinoids and also for isotopes. So these are the some demerits of Mendeleev's periodic table. So in this video, we have discussed about a few attempts made by scientists to classify the elements in different ways. I hope it is clear to you. Thank you.